I'll pick it up. Yeah.
I never called them before. Like, it just
Yeah.
was fun.
It was good. I want to ask. Yeah. They put me on hold like 5 seconds.
Well, yeah, because the phone is right next to the register.
Oh,
there was probably some customer from
some people. Yeah.
Because I think we're going to need something like that tomorrow.
Yeah.
It's not 65 volts.
Oh, 65, yeah.
I mean, how's your drive? Just
Yeah.
It's fine.
Yeah.
No,
I just went to the road and.
Oh, is it?
No.
Actually, I think today I'm going to try and. I'm going to try and take apart the code and pour it directly.
are you streaming? Jeremy?
I just put it up.
Oh, I think
It's just not set up for so I think if I could just fit anything else or something like that. I could just
electric, copy,
because then literally all we have to do is I would like we don't run with the batteries, not big deal. Because I'm motivation. You just run code, you take the picture, save the SD card, and go button. Like the buttons.
Okay.
Every time the button's pressed, it runs through it. It's for button mouse. Turn on the LED.
Yeah. So, I think it, time recording video, I saw this example because using that same camera, it's pretty good. Is that your key?
Oh yeah. How's that? See.
It's okay, it's hooked up to the files. It's in there. It only shows you one of the files it reads from.
Yeah.
It was multiple, so you don't know what you did wrong. Because you can't see the file it's reading from, and you're just parsing it out. That's it. But he also pretty much gave everyone the answers in Zoom chat today.
Oh.
So I'm going through that.
What's Gino?
Scotty.
Just as complicated.
How will it get pizza? How will
We're still using the CM4C with the camera.
Why would you do that? I'm sorry, I'm asking out of educated in the subject, but like, aren't PCOs like formatted or outcomes?
Depends on what you buy.
So that would be used.
The whole time.
Stay in months.
You know why it's called Python? Jeremy, do you know the name Python comes from? With the programming language?
I do not.
Is it from a snake?
No.
What is it?
Where is it from?
The guy that designed it was a big fan of Monty Python.
Oh, okay.
That's why all the examples use like span eggs, because it's like a reference to a famous Monty Python sketch.
That's cool.
Good to know.
You've never seen Monty Python?
No, I just watched the National Treasure list because there's 4 seasons that I haven't seen them.
You're missing a lot and not that at the same time.
So I'm going to give everybody a file in KiCad to start with, which is kind of like where we were kind of ish at the last workshop with some, but I redid it and made sure all the parts were selected right. But it's KiCad 7. So if you installed KiCad 6, which you probably did because KiCad 7 just came out 2 weeks ago, you need to update to KiCad 7. And I'm sorry, I was going to tell everybody like as they came in and I forgot to until now. You just have to re-download it from the website and install it. I know that's a little annoying, but there are a ton of cool new features in KiCad 7.
I mean, it's easy to download. The download, I don't think there's I don't think it's the download. Yeah, I saw this morning. This Jane up there.
Yeah, I want to, that's a great,
Yes.
the nose there and all.
I mean, it's.
Yeah, hopefully I'll get to just go like.
So my graduation earlier, like
Yes.
water.
Yeah.
Yeah, me too.
No, I applied for graduation last year.
Last year.
And so, they updated my graduation to the spring.
Gotcha.
So for this, yeah.
This water.
And so I should be good other than this. So
Oh, you're right.
I'm like, I have 2 weeks to figure this out
If
otherwise.
not, like you said, you'll be one quick exception.
That's what I assume. I just want, like, I'm wondering if they just allow when
Transfer.
Let me get a drink of water while
everybody's, you know,
Yeah.
like update it.
and then we'll start.
Do you have no cups?
I'm not seeing any.
Oh, okay. I'll grab some.
Are you already updated? All right.
Yeah.
Yeah, I think like maybe 2 more days doing that, and I think I could get some cooking. Yeah, but I'm wondering, like, honestly, though, I think we'll get, we get the, like, I think we honestly, that's what I
Josh said that too.
Yeah. I feel it.
Administrative rights to put. You can't send it.
No, it's, oh.
Are you gonna see the checks, you know?
Good. I'm not sure what is the file that we, says
Whatever it is, file it is. I'm gonna try it. Maybe while he's in here,
Oh,
Just tell Jeremy to use this one for now.
I have to pick up the.
Okay.
that's if we wanted to get it running on the email.
Oh, wait, I'm wrong. Because I'm wrong, actually, because the thing is, it's not set up for it yet. So we can just drag and drop in. You're right. You're right. That's what I was doing on this. SSI. It's installed. It's issue with it. Can I try and install it?
you guys.
I was trying to see if I needed administrative rights.
Oh, right. Looks solid. Quarterly for distributor. I hope. Try installing it instead of there, if it does, it works. Oh, okay. Let's see if it works. So I went into program files. So you go to C drive, program files.
there it is back at, oh, that's 6. Yeah, potentially working on it. Try installing it, but install it in your documents folder. I'm gonna guess the reason it completed so quickly is because it just said, yeah, sure, I'm putting the files there, I promise. Over and over again. Hey guys. Hey. So we're all updating to KiCad 7, which in hindsight I didn't even think about the lab computers. Because KiCad 7 just came out, there's a bunch of cool new features in it. So I started using it and I realized afterwards the file I made is not going to open in KiCad 6. So I'm going to be on KiCad 7.
Cool. I'm glad I didn't do the whole workshop 2 video event just for that to happen. Yeah, maybe.
Whole page.
Whole page, upstairs, couple other things. I never even heard of them. Money wants a whole page on them. It's like, write about why we don't use this. Why do we print a whole page? Because that's exactly what it says. Yeah.
Okay, that's it. Yeah, whole page.
Is it less than a full page still, not a page?
That's what I'm saying. I don't know.
Page is just not-
No, he didn't specify the font.
Yeah.
That's so funny when he gave us a cheat sheet, he specified a font. He must be handwritten. Oh, your progress.
Here's hoping.
I think, maybe they just gave you like,
Go and bin of the binary delete for the type something you see in there. Not a schema specifically, there it is.
make
Yep.
copy, default copy.
Yeah, just do default. Okay. Cool.
And make copy. Good.
I was a little nervous there for a minute that was going to be a major problem. I was thinking of like going manually editing the file because all the KiCad files are actually just text. So you can get in there and change the version number. It's a matter if there's actual true incompatibility or not.
So for the MyPico,
Maybe
the 240, is interfacing the GPO things as directly as if it was on a breakout board?
Exactly. So for the sake of people on the stream too, using the pins on the Pico is exactly the same as like if they were on a breakout board. You just connect them to whatever you're going to do. That's all the breakout board does, is it just gives you somewhere to plug them in.
I'm just curious if there's like any hardware between the pin and...
No.
Okay, so there's no like voltage protection, there's
No, and actually this is, the Pico like board itself is extremely slim, but all these development boards usually don't. They don't do anything to protect you from yourself. They're completely fine with you, say incorrectly connecting UART, because like UART you have to do switch RX and TX, and they'll like fry each other on a lot of these boards if you do that. I usually, on that, like I add a resistor so that you can't overcurrent it by accident.
Yeah, I was kind of curious about that. It's like I know the Arduino Uno, that's like a tank.
It's more that the controller is, but there's nothing added on the board.
Okay.
There's nothing like on the board to do that. And if you look at the original Arduino Uno, they just have a socket for it. So if you fry the chip, you can put a new chip on.
Yeah,
So
that makes sense.
I've never fried one of the chips themselves on the Uno, but I have done it on like a board that I made.
Is the limit for this like 250 milliamps?
Oh, I think it's probably way less than that. 50 is a lot. 50 is a lot for these. You can see in the data sheet what it actually is, but usually I figure on like, just to be safe, no more than like a milliamp out of each pin. You can get more on a lot of outputs, but when you do, usually there are rules you have to follow. Like you can do 2.5 milliamps on this pin, but only 10 milliamps between this group of pins, and then this pin can only do a 0.5 milliamp. There's usually stuff like that. The RP2040 is nice because it makes all the GPIOs pretty much the same thing. The only deal is for UART and SPI and so on, specific groups of pins make up a peripheral. But you see there's not like, it's like, here's all your GPIOs, use them as you would like. Instead of being like, oh, here's port A, port B, port C, and like a complex map of all the different functions. So did you get that opened up? Yeah, I would just re-download it and install it. It'll install it in an older program. Yeah, it'll install it. Yeah, it literally, they don't interact with each other. It's interesting. That's because they're doing revision.
Open up the box and there's just this package.
So KiCad 6 or KiCad 7 is like a whole new software release for it instead of just advanced. If you added things to the built-in libraries, then you would. Just don't worry about it for the moment. Just open up the new one and run it, and then uninstall the old one at some point.
Used to hire as porch pirates. Was that you that told me about it?
No, but I have seen that.
Oh, up to you. I would start with default, so we can go to the
Where was the?
It's right at the bottom there.
Because somebody showed it to me, and then I thought of you because you were talking about porch.
Oh, you're good. I'm just happy about you guys all showed up with the snow and everything.
This is like the most exciting class I had all week.
Yeah.
Second to engineering, which is also a very, very exciting class.
Could everybody let me know when they finish getting this file up, and then I'll talk about it?
Are they working?
I already know, you've been here for hours, Timber. So that's on, I posted on Discord. So this is basically just from the last workshop, except I redid it and made sure all the footprints and stuff match parts that we have. So it's basically like, you weren't in the last workshop, or you didn't do it follow along perfectly, or you copied the same mistakes I made in the last workshop. This should all be good.
I'm glad you did that.
I totally didn't sleep last night because I did this. Rebuilding this whole thing and trying to find like the right chip to use and all this stuff took a while.
Totally, I didn't see you off there. Some pictures.
Yeah.
Is there a special way I have to uninstall this, or can I just?
Oh, you could uninstall it through the regular uninstall if you pressure Windows key, type in UNI, start or install, add or remove programs. And then somewhere in here there should be KiCad 6. Just do the search at the top of the box. There. So yeah, so there's KiCad 6. And you don't have to uninstall KiCad 6 to install KiCad 7.
Oh,
They'll actually work alongside each other, no problem, they have their own settings and everything. So, it's the first start of the first workshop all over again, installing KiCad. At least for me, like there's a new rendering engine on the back end of KiCad. For me, all the schematics, like navigating through stuff is so much smoother than it used to be. It's pretty great. There's like a big list of all the new features that they've added to. There's an auto router now. So once you place your components, it can route all the traces for you. Or try to, and it'll let you know if it fails.
I was thinking it should have had an auto router before.
So there was a lot of pushback from like, the community in KiCad because they put a lot of work into what's called the push and shove router, which you'll see me use today. They're like, hey, the push and shove router is so great, you don't need an auto router. But now, I haven't actually messed with it yet with the routing because I just drew the schematic, but you can just go and be like, finish it for me, and it'll route the rest of your board. So you place your components and then tell it to figure out the routing. That's not going to be perfect for everything. Sometimes we need to route by hand. But that's one of the cool things added in.
That's the time, I guess, where you just like,
Yeah.
and then just walk away.
So there was somebody that in 163, because I went way overboard and did a PCB for my final project. There was somebody in 163 that wanted to do like a 7-stage display with RGB LEDs, and he had like 200 RGB LEDs with 6 pins each. And I like kept trying to steer him. I was like, maybe tone it down a little. He really wanted to do that, and he started routing it out. So you have 200 LEDs with 6 pins each going into all your different controllers, and so you need like thousands of traces. I figured out how to get the old crappy auto router working for him to do it. It actually managed to get it all done.
That's
But
awesome.
the new one is apparently really good. The blog post like showing it working seemed to be pretty great.
The workshop 2 video at the beginning of that, when I pulled that up, it was like, was that you editing it, or was that the auto routing thing where it was just full line?
Yeah, so you
need making connections.
Oh, so that was a time lapse video of me doing the Squid Game board.
And I thought that was real time. I was like, oh my god, this guy's insane with this. That's so funny.
No, that was 40 minutes compressed down into 5 minutes.
Yeah.
And I just left that up on the screen while everybody was coming in.
That's okay. I was like, jeez, man. Yeah.
Yeah, I'm not that good.
It's like the skill ceiling on this is high.
It looks like everybody's getting close to having everything up.
Should I have the biggest settings or just default for 7?
I usually do the defaults.
It's okay.
I got this.
Oh, no, that's perfectly fine. You get this. Just copy the global footprint table. So it'll say that every time you install a version.
You don't have it on
It does, but I forgot to confirm it on the email. You know, you have to like.
there. No, it doesn't look good. You don't have to do that.
I never knew about that. But seriously, you could just go in. I can't believe it. I've been like, you know what it does too? When it tries to connect automatically, it opens Chrome and it spams me with tabs.
This
This is where we need to do your partner with them.
That's so funny.
So you guys were all getting that.
Oh, yeah.
Okay, we're just waiting.
Yeah, that and
Do you guys have the file pulled up?
Yeah, I'm working through that. I'm going to take it with different. We'll just get sent to the.
But you don't lose them.
And I just have it.
Really felt.
You should have seen me with the trackpad, I forget my mouse, and just stand up and like, I don't know. How do you know? That's hilarious. I was asking Dr. Bill about it, he's like, oh no, have you connected to Wi-Fi?
Yeah, I think that was, I don't know what it's called.
Yeah, no, that should do this one.
That is not
That's
a program.
That's an announcement for it.
Yeah, I'm gonna put the circuit inside of that. Oh, just a little first door and get 2 cheesecake.
That's a good idea.
And then like everyone's.
I guess, yeah, that's.
We have one viewer on YouTube. So somebody wants to be here but isn't.
Sorry, that was me.
Oh, was it you?
I might just use.
Maybe
I'll go buy some Boy Scout pop.
I'm going to try to leave the chat here in case that person has any questions. Ethereal viewer on YouTube. The link to this file that's up on Discord to download, and then we have to update to KiCad 7 if you haven't done that. And everybody's just about updated, so we're going to get started soon.
But it doesn't have like it's very laptop. Nice thing is it's really thin, so it's easy to practice. That's cool.
I like that.
You don't have the custom UI, but like it's a custom UI.
It's not that way.
I was kind of curious because they got a UI where it's,
Oh, yeah, no, it's just. Yeah. I think there's really a program for other stuff.
Show me what kind of file downloaded. Did you extract the zip file? Or are you just looking inside? Okay, you'll have to extract it. It's probably looking at can't open this.
Have you finished the project or
No.
You're lucky if I can do it on.
I'm not too worried about it.
No, I didn't think it would be. I tried doing my comment and
Circuit was screened at 5 volts.
Mhm.
PCC 5 volts, like, when I usually done that here. Gonna try to define that into 2.5 instead of trying to work with 5 on top. That's everybody go to plan on it with that.
This is having you read it off.
No.
So, I've been busy with other stuff. That's like, if I understand it, it's a rectifier and amplifier and speaker, so I'm like, I don't know what his requirements are specifically, but, there's no reason you shouldn't be able to use VCC 5 volts directly for your amplifier. You just pick your operating point, VCC equals 5 and all that. So, there's a right on that in the PCB, there should be schematic.
Tell Meyer that he's using budget to buy $10,000.
So are you running KiCad 6? So when you double, you look at it, that's what's up.
Yeah, so
And then go to here, so file, and find it in there. So what's happened was when you go to the it's still installed.
I guess nice for prototyping, but then all this stuff, it's like.
And then if you work it, yeah, that's it. Or it opens and then you're gonna have to open it again.
because each one I can open with 7, they don't.
Really? Okay, so let's try this. Let's try this and see. Get us here. Now, there's a double door on the schematic here. There you are, uninstall 6 if you have any issues, and that should take care of it.
So, being that we have that ability to share our work between CUDA and OpenGL, you can't do it on a separate circuit because it doesn't support it. So I just did these 3 methods. Initialization, update, color, frame, and then
So that's it.
Yeah, but what if we want to render, like, explore without the game of life render? See what I mean, like pause it and look at things?
well, so that's why they're in separate things, and I also provide the time. So if you look here, this update, I provided the time.
Oh, okay, so it like bring the time to when.
You literally use that, like, it's basically a timer rule, just like how we used it in our assembly code, where it's just as time goes by, so you can literally just save that variable and compare it. Like, oh, we only want to update, only want to run every 1 second, we can do that.
That's probably gonna be way less frustrating when trying to use your pad.
And then I actually have a little GUI interface that you can have, if you have some other variables like pause, game of life, or other things, I can add that.
Cool. Alright. Okay, now everybody has KiCad 7 installed and the file open, so let's get started a half hour after it actually started. That's not too big of a deal today. So I have this file already opened up as just like a base using the RP2040. I went through, made sure all the components are components that I have or can get, and we will get them, so they're available for your boards. The idea is that everybody can use this. If you have some other design you want to do, you don't have to use this base, but I'm just using it as a start to, hey, this is a working microcontroller that you can program code and interact with whatever other circuits you add in. So you see, like, I have the GPIO here just set all up with all these flags, there's nothing connected to them, and that's for you guys to try and decide what you would like to do for a project and add to it. I know not everybody really has an idea what they want to do for a project, which is fine. Just kind of think about that over. I was originally planning to do like fabrication after this workshop, but I think fabrication is going to be like spring break or after spring break, because I don't think everybody's going to be ready in a few days, and I have tests next week and everything else, so I think it's a lot more reasonable to have this and sit on it for a little bit and think about what you want to make. A few people have come to me and said, I'm thinking about doing X, how can I do that? So I would encourage everyone to, you can ask me here, or you can ask me in Discord or anything if you want to do something and you're not sure how to do it, to actually make your design. I can probably point you in the right direction. So what we're going to do today is, this is also the base I'm using for making a board for ops for IEEE, and this is the base that I'm going to use to make that board. So I'm going to go route this out and try and show all the features of routing and placing all components on boards and KiCad, and how to make the fabrication outputs. So everyone can follow along. They don't have, your result doesn't have to be the same as mine, and this will just be this portion of it, and then you go and add your extras to the design later. So if you want to add some potentiometers for an input on there, or you want to add 7-segment displays to output something, that would be for you guys to add on afterwards. So just real quick before we jump into the PCB editor, one of the things that's really improved in the new version of KiCad is hierarchical sheets, and it's actually open by default on the left. There's this new button on the right here for add hierarchical sheet. I'm probably mispronouncing that, but when you press this button, you basically draw a box and you give it a name, and it creates a new sheet for you. So I'm going to say my additional things that I'm going to add in for ops, which I'm not going to do it here right now, but I can put it into the sheet and do the additional, or set the file name. You can also import other schematics. So
you can make this thing as a template
Exactly. Exactly. So you could import, if you wanted to start your project from scratch, you could import the schematic file that I just gave you guys out of the project as a hierarchical sheet and have it as part of the project. So when you go create it, it makes this little sheet here, and then you can do these hierarchical labels. So like, I'm just gonna call this one input. When you go and put a hierarchical label, when you go down to the sheet, those labels connect to each other. And that's how you basically like make connections in and out of the sheet. So there's like input here, that'll be the same as input up here. So there's like a little bit more nuance into it and making it all work correctly and stuff, but that's pretty close to what you need to do it. So if you want to do your stuff as sort of inside of a sheet, I have these all set up as global labels. The global labels are across all sheets, so you don't even need really to put the input there. And there's this V3V, or hold on, actually I need to, could everybody, because I made this mistake, there's this V3V3 label, there's like one right here, duplicate that and go up here and add it to this. I'm just gonna move this stuff out of the way so it's readable. The reason being that way you can use it in a hierarchical sheet elsewhere. So this is your 3 volt regulated output. So I just wanted to talk about that. So it's a good way to integrate different pieces of a design. It also is the way to duplicate design. So if you have like a driver for a motor and you did your whole design, you can include that sheet in the hierarchy multiple times so they're all identical. So as you work on bigger designs and stuff, like this didn't work so well in the past and I didn't use it, I just ended up duplicating things. So it's nice that this is added in. Who wants to start with routing right now and who wants pizza?
Pizza's hot, so.
The pizza is hot.
Yeah, let's go.
Let's do pizza first since Nat just brought it in.
Yeah, and pause so I can call over to it. Whoa. 22. Yep.
How much was it?
One over 32, one over 34.
Well, that's actually a pretty
Yeah.
good deal.
I don't know how big they are.
That's why I got these places. They're decent pizza and they're huge.
Given the attendance.
Oh, sorry. They got, like, it was too big for my car. Huge. Oh, and also they don't have gluten-free or vegan, so this is a normal one. It's like pepperoni and
We have plates.
we have plates over there. The place could be small though.
Yeah, but it's better than nothing. Alright, there's the soccer plates.
You guys don't want pizza? Get some pizza. We have a lot. Honestly, get some pizza. Before you leave. Okay. Yeah. See you later. See ya.
It's the stuff the same as it always is.
Me too. I don't know what we were guessing.
I think the sweet spot is between the,
Yeah, so these flow, so each one of those slices are $5. It's just cost per soup.
So this reminds me of like, there's this ancient Spider-Man game, and I don't know why, but there's a delivering pizza mini game. So if you like do flips or whatever as Spider-Man while you're carrying the pizza to destroy it.
No, like after you can
already remember what that game was on. I was a kid. That's what this reminds me of.
Yeah,
He's the director, so
I
think he knows.
Yeah, I already emailed that one, and I was actually gonna make an email or a couple of weeks ago.
Yeah.
I figured.
Oh, by the way, I already added a little GUI icon to the OpenGL where they can turn on and off the call to update.
Sweet.
So the CUDA update call can be stopped being called every frame. So if you go ahead and so if you go to
Yeah, I think this is unironically New York style. You just have to fold it.
so the thing and then after that you go to preference, and then go to schema, editor, color, and then
You run it on this. He knows you order the sandwich. I was taking your order. Okay. But I mean, yeah, I guess that's what you're saying. It's weird.
Accessible free
What are you looking for?
There's also.
I set some between them. These are all.
You got here just in time to be it. You didn't start pretty much until half an hour, you know, because everybody needs to upgrade the content set.
This is on non-veg?
What?
This is on non-veg?
got it.
pretty much what's out the times.
Okay, I'm actually going to get started on this now. So I'm just going to click the little open PCB board editor to get over to the board editor. And then in here, I did all the stuff we I showed last workshop and like pre-set up all the fabrication limits and so on in here for you guys. Like we went over, so you know when you do a design how to do them from scratch in the last workshop, but I'm not gonna make everybody do it again. So that's already put in here. There's nobody on YouTube, so I'm gonna take that down off there. We have to click the update PCB button up here, like right in the top middle. And that should give us all of our footprints. And I'm just going to click update PCB and drop them in here. And then might be kind of hard if you're on a smaller screen, but I'm going to show these side by side so that I can see what goes to what as I'm working on this. There's a new auto place command, but I don't know how to get to it because I haven't used it before. So it will like try to place components for you where they are roughly near where they need to be. I don't know how good it is, but you probably won't end up doing that very often anyway. It's pretty much after you've imported everything in, you have this rat's nest, shows where everything needs to be connected, and I'm just going to grab the microcontroller out here and then start thinking about where everything needs to be relative to everything else and placing them out here. Again, this is a design that I'm actually doing for our ops program, so I didn't like go through this ahead of time to see what is going to be best. So I know I'm going to have the microcontroller, and then I know the USB is going to be over near a board edge. U2 is the voltage regulator and should probably be close to where the USB input is. That's where the voltage is coming in, or the voltage supply for it is. It is huge compared, this chip's actually pretty darn small for a chip to be doing on a board like ours. This is probably, I can probably get everybody to be able to solder these, but I'm going to solder this chip on for everyone, I think. But it's kind of hard to do it without frying them because they are pretty small. I know that these diodes go with this, so I'm literally grabbing it and looking at the rat's nest and then thinking about where would be a good place to put this. Like, okay, that needs to be near this. This can go somewhere near the USB, rotate it around. I think I'm going to go down to 50 mil grid. I haven't drawn a board edge yet. So the way you would do the board edge is this, on the right here, there's this edge cuts layer. And whatever's on that is the shape of the circuit board. I thought you were making a face at me, then I saw you're taking a bite of pizza. You look like you're like, ooh. I was like, I didn't think I said something wrong. So let's see. So that's going to be V-bus there. This, rotate this.
Everybody's just like multi-folding them.
They are a little bit comically large.
Sure, each one of the slices is only $5 there. So it's pretty awesome with how large they are.
Yeah. Okay, so the next thing in my mind that's really important to get on this, for routing this out, the important things are the USB connection, because that is at 12 megahertz and actually has requirements for impedance. And the connection for this chip, which is the flash memory that our program loads to and runs from, and that has to be like, it runs at 133 megahertz, which is rather fast, and it needs to have short connections. It needs to be pretty much as close as possible to the chip. So those are my main concerns as I'm trying to go and lay this out. Probably something like this, I guess. Right there is probably the closest I can get that. And then
I got my own place to work.
you did?
Yeah.
Where is it at?
So, you know, the file edit view, it's under place.
Oh.
At the bottom. You just need the edge to find.
Oh, okay. I will give that a shot. Let's see. I'm gonna here.
It loosens up the pile. That's
It loosens up the pile.
Yeah.
Let's see. I'll define a board edge real quick, and I'm gonna try that out. About
Of
this
course, I
much.
would put the USB in the middle of the pile. So.
It did.
Mm-hmm.
Yeah, it doesn't know. I wonder if it lets you. It's like, let's see, USB be somewhere around.
Make it autoplay selected. So.
It's autoplay selected? Okay. So I can select all these. Then do autoplace selected footprints. Hey, there we go. Yeah, I'm not sure if I agree with where it put things, but it does exist.
It stretches up.
This is like the AI of getting things done. It's like, it technically all works, I'm sure.
On the board.
It is on the board. Yeah. Okay. I'm going to define the board footprint later because I don't know what size it's going to need to be until I add all the connectors we're doing for ops. And autoplace doesn't know about the requirements that this chip needs to be close to this chip and this needs to be close to this. It doesn't know about those things. Okay, let's see. Move USB a little closer here.
It wouldn't let the use 3D view, and then you'd be like, oh, okay.
Yeah, I think the only thing that won't show up in 3D view is the RGB LED. Oh, yeah, in the USB. Oh, I guess this was actually a pre-made footprint. I didn't make the footprint for this one, but I made footprints for the Crystal X1 for the USB, and I based it off an existing footprint though, and the RGB LED, which is this right here. The rest of them should all have footprints to show you. So the USB has these series resistors.
So if you see a capacitor, just put it next to the power supply board or the pins.
So actually ignore the capacitors for a second because I think we're going to put those all on the back side of the board, or most of them, for this. And this footprint's really meant to have that done with it. If you look, there's a lot of chips, when you look, they have grounds scattered all about the pins. On the RP4020, instead they just put one huge ground pad on the bottom of the chip. So, like, this chip is not solderable with like a soldering iron by hand. You have to have hot air in order to solder that pad. But when they decided that was okay, it made sense not to use up all their pins for grounds.
That's genius.
So, I guess, oh, that was weird. I have my nice 4K monitor at home, makes it a lot easier to have everything open all at once and look at it. When you do the capacitors, you want to look and see what they're in relation to, because there are multiple capacitors that are between the 3-volt rail and ground, but they're related to a particular chip. So you want to put them with the chip they're related to, even though there's not like information for it, and that's why having a large enough screen, you can go and open them side by side like this and be like, okay, well, I have this chip right here, so let's look, that's the capacitor that goes to it. Let's put that with this chip. F, by the way, flips the component to the back side of the board, and then it'll turn blue. And I'm just trying to get everything placed. I'm not worried about getting components routed yet.
You guys can't see the render in the 3D.
Yeah, the 3D view is just for looking at it. Let's see.
Oh, it is, yeah.
Is anyone on YouTube, Karen?
I haven't looked in a minute because there was nobody there earlier. Somebody came and checked in, but
2 views.
yeah.
Carl-
This is less lecture-y today too, because I just have something to work on.
Yeah.
And when I get to parts, I'll talk about them, but my encouragement to everybody is here's something to play with, and then
Yeah.
we should all, or try and discuss what designs you want to do after
Yeah.
I finish routing this.
And I think everyone here can do the ops mix for to actually use this board that we designed, that we designed.
those C1 and C1 to C10 under the chip already are putting them right now.
Yeah, I'm putting them there right now.
So what are these specific spaces made for? Like the red spaces, red bars.
The what spaces? Sorry.
Red bars on the chip 57 GMD. The red bar on the border of the.
So are you asking about?
So
Yeah, maybe his point. That's going to be easier than trying to.
So I'm asking about these things. So aren't these the already the chips that we put under them, like under the?
Oh, so the red bars is what you're asking about.
These
So the red bars are the copper pads is the terminology. So when you have a chip that you're going to go put on a circuit board, it needs to make connections to it. So we expose a bit of copper on the board, and then the pin comes down and you set it on the board and solder it to it, and the solder sticks it to it and makes that connection.
Those are for like soldering them.
Yeah, so if I go to the 3D viewer here, you can actually see more what it is. Oh, so the chip's shown, you can't really see it on this one. Turn off, there we go. So this is what it's going to look like, sort of, when it's manufactured.
Yeah.
And then the chip goes on it, and this chip doesn't have leads, so the pins just sit on it right there. And that's what it is. And then that's just like an opening in there where the copper is that we make the connections. I did the number of capacitors according to their design guide, but I'll be honest, it feels a little bit excessive. Usually they make, when companies put together the design guides, they're like, we want to make sure it's going to work rather than what's the minimum required. And that's why we have a bajillion capacitors on here.
And the purpose of that is for bypassing, or is it?
Yeah, for bypassing. It's for, and I talked about it at the last workshop too. It's so that when the chip's operating at a high frequency, 133 megahertz, this one operates at, it doesn't have to worry about the line inductance to wherever the power supply is. So you put a capacitor near it, it bypasses it.
Yeah, it's good practice.
Yeah. It's one of those things that if you took it off the board, maybe it would work, but you're much less guaranteed it's going to work. Like, I played with chips at like 72 megahertz without any bypassing capacitors and didn't have problems, but that doesn't mean that there wouldn't be something that would crop up later. That said, I'm considering axing a few of these capacitors because there's not really going to be much difference. And I'm going to have to solder them all on.
That's the best part.
Is it? So when we get all these boards in, we're probably going to end up doing a production line of people placing components on boards and soldering them all together.
This is going to be factory in here.
Sweatshop.
Yeah. Tell everybody to wear their sweats. It's a sweatshop. This isn't a workshop. It's a sweatshop.
We're all over 18, so we should be able to not It's just
This is what all the free pizza leads up to. Everybody needs to come here and then
Yep.
place resistors and capacitors on these, because I'm planning, this particular board that I'm laying out, I'm planning to make 30 of them for our ops program. So we actually have a lot to do, as opposed to I will solder one board for each of you guys when you make them. If you do a BGA, I don't think I offer that service. If you wanted to do a BGA, I'd figure it out. I've done BGAs before. They're not fun.
What's BGA stand for?
Ball grid array. Here, that's actually a good question, Nat, because I just said that and didn't explain, and I haven't explained prior. So when you see a chip and the bottom of it looks like this, that's a BGA.
That's when you just use the heat gun, right?
Yes, sort of. So if you go in actual manufacturing processes, when they do BGAs, well, not even, so usually you use like a wave oven, an automatic machine, but also, how do you verify that every pad made a good connection?
You plug it in.
Yes, but also it ends up being you need x-ray inspection to actually look at it. So, and I have a lot of equipment in my garage, but not that. No, I don't have an x-ray machine. And honestly, since my wife's going to be a medical provider, I'll be more likely to have an x-ray machine for people than electronic components in the future.
Just create a box that doesn't interfere with the x-ray, and then just have all your, then you can use the x-ray machine for people. A box that looks like a person, you just put your electronics in there.
Mm-hmm. Next time I break my leg, I'll go take the board and like just put it on under my pants, and then go in. I'll be like, "Can you make sure to get a good look at the leg? Can I keep that X-ray?" Like, what is that? That is just a project. So yeah, when you get up into more highly performant components, it's like all ball grid array when you need a lot of pins. One chip that I really want to actually get into using is the AM3358, and I was leading up to doing the soldering for this. Where is it? This is like a map of all the pins on it in the data sheet, and somewhere in here I think they have a picture of the package.
Can you tell it to choose the closest instead, like, based on schematic closest instead of physical location?
I don't know if, like, I've literally used KiCad 7 that added all these nice features for 12 hours last night before coming here. So I don't know yet.
That's the chip on the Beagle board, right?
Yes, this is the chip that's on the Beagle board. So I could get a Beagle board, but that's not how I roll. If I'm going to use a chip, I'm going to make sure I can solder it myself, because then you're stuck with whatever Beagle board, or whatever they think you need, versus being able to pick your own RAM and all this other stuff. So I sort of I could have sworn there was a picture of the package, but it's not that important. I don't like, this is the new rendering engine, but when I scroll to the side, it like tries to move a whole page like that, and like just throws me off into the distance. So these are like these.
2 centimeters of the surface area. Would you be fine with that?
If you put all of what?
Put everything on like 2 centimeters worth of surface area?
It's all up to you.
Okay.
There's not really, like, we pay the least amount of money if everything fits in 100 by 100 millimeters, but that doesn't mean that anybody's limited to that.
I know my brother was just go like straight out like a wad of components.
Mm-hmm. Well, especially when you have high frequency stuff, that's not a bad thing, trying to get everything in as close as you can. You go and look at something like a motherboard on a computer, and the top layer is literally just components wall to wall with no space in between on almost the whole thing. And it was just, they needed the components on, and that was, that's their limiting factor. And then they have, 8 to 16 layers to route it all underneath. Let's see, what is C12? Oh, loading crystal. So when you guys get to C12 and C13, those are part of this circuit right here, which is the crystal oscillator that provides the reference clock for the chip. It's really important all those things be tight because, like, we're adding a component with 14 picofarads of capacitance. If you go and do the calculations, your traces add a few picofarads to that. These values actually calculated out to 15 picofarads, or sorry, 18 picofarads, and I reduced them to 14 because of the extra capacitance that'll be added by the trace to try and make sure it's matched well. So you see in here, I'm just going to put those like right next to the crystal that they're going to go with. Yeah, I know the grid just not. That's one thing that's kind of frustrating is because some components are inch sized and some are like metric sized.
Yeah.
So they just don't. They don't line up perfectly on a grid with each other in terms of their sizes. And then there's a resistor with the circuit. I'm gonna have to see if there's a way to change that behavior because I don't like getting thrown off into space. That'll do. So something I'm going to do because I have all this stuff that I put on the back side of the board and I don't want to look at it while I'm working on the front side. On the right hand side there's the appearance tab here. By default it's on layers, but if you click the arrow and go over to objects you can turn off different things. And I'm going to turn off footprints back for now so that I don't have to look at or think about those whilst I'm doing some other stuff on top. It'll still show the rat's nest to them, but it's just going to make it cleaner. Like specifically I want to move this over and it's going to be right on top of all the stuff underneath it, so I don't want that in the way. What is C2? Oh, C2 is the input, C2 is the output.
I have a real appreciation for these.
I'm not doing the questions.
That's the fault. I saw the movie. I'm used to it.
I didn't see it. Jim's I think he also did this. Probably.
He talks about Nintendo. It's like he's talking about.
Yeah, Michael.
Yeah. He's talking about.
Actually, it's interesting to hear what do you do for this Rogers does like his PhD is on my group, so there's so much about it. He'll be able to.
Do you guys know who came in and sat over there?
Doug,
Doug?
he's a master CS.
Oh, okay.
He's with the ACM.
Yeah, so he's taking classes. He's taking classes as well.
Yeah, he's doing master degree. Is your mom teaching?
Yeah.
Oh, really? She came to talk to us about like she wanted to be involved with the IoT
Yeah.
stuff.
Yeah. She's planning to take one course. Like planning to start a course for IoT next year, I guess.
Yeah.
Fall, something.
Saw your brother too.
Yeah.
He came down here.
Yeah, he wanted to. He knows everything like Tinkercad and all.
Yeah.
So he used to 3D printing. He went to the lab to design as well.
The lab design.
Design.
Oh, yeah, they have. Like,
They have two printers here.
I think they're just better. Ours is like
And we use those printers. Like
we
you guys.
use one not that much. It's Mesoprops
Oh.
calibration.
All that.
Yeah, there it is.
So I just use these, I go to press and just, it's close. So we have a ton of switches. A ton of these.
Oh, how many of those do we have? 10. Yeah, so you're right, we do have at least 30. Okay.
Yeah, in case you wanted to, I mean, LCD would be cool too.
I'll see how much a socket costs. Because then we don't have to put them on every one also.
That's true.
If the socket's cheap enough to make that worthwhile.
Sure.
And we were looking at questions.
Yeah, well, maybe you want to, obviously, days,
Projects and stuff. Especially IoT.
Like, it's gonna be a long stay, here.
So you guys are over here.
It's a little better.
The couch. It takes a while to get used to doing it. Sort of wheels, like stuff. Batteries on it. Power bill.
What's your, how do you feel like?
I'm just remaking the part. I'm just remaking the part of the game, trying to make it harder.
Instead of art.
Oh, so what's that doing is it always draws the closest connection that has the same net.
So we can fundraise.
So it's saying,
Yeah, so like just the same thing that you're doing, but like place it so it looks like Eagle.
Yeah, so, okay, so here's
so
the
like if
thing.
you're dragging it.
I can
it's
kind
showing
of, I can do basic
dragging
geometry in
it.
here. But if we want something complicated like that,
You don't see that.
I'm assuming we can just
As you're
import
dragging
from
it, you're like looking through, so this has ground on it.
Yeah.
the design.
Or
and
actually,
environment
So it shows
thing.
the ground
But I
cap
have to
is the
have it
closest
to the actual
thing.
board.
And then this right here.
Yeah,
You know, it's
It could be like a simple.
And on my
simple
controls,
design,
they're always drawn to.
a little less.
Yeah, if you had a different
Yeah.
net, the same net, it'll show it next to
Extra
that.
thick.
So it's sort of like, you can actually, like, you know, you have a component that's out in the ether, you can pick it up and like shake it and you know it's connected to here, this piece.
You
is
start
right down there.
and based on that, change the shape.
Yeah.
Then you
It's
get
like,
in,
sounds
well,
easy,
connect
but
this,
it's
it
extra.
tries to help you
Well,
visually
if
find
we
what's
want to do that
gonna
one
be
just by
the
phone, we
closest
just
thing
have
to where
a
you're at.
Eagle itself.
Yeah.
We just give it
the
a through,
switch.
just give it a through, just
Through all.
SMD the whole thing.
Yeah.
So that's why you.
Because the other one doesn't have a switch.
No, it doesn't.
Plays and Carl is trying to
Yeah,
best.
so,
It worked though.
It worked once I told him he was short circuiting
Oh
it.
yeah, that's right. Like his battery was like super hot.
Well, yeah, because he was short circuiting it.
And this one can actually, if you wanted to,
Yeah. And then
you can
We're
like
at the whole
yeah.
board,
Uh,
literally all.
So I can switch to this. It's not too hard.
And switch it and make it like a amazing thing. So you, yeah, you can put that on your get on
Yeah, well, I'm just gonna change the design.
There's a way to put the whole.
Yes.
There's no
I'm gonna
point
find
in
out.
doing that, it's just like something that, are we gonna sell it, or are we just gonna give it away?
Yeah, so
Sell
we're
it, sell it.
trying to work.
Fundraise.
They,
Good time.
I was
like,
thinking
probably
too.
it's like a couple of bucks depending on the board you want.
So we can sell it anywhere. We can sell it for 10.
If you want to.
Even if, because the Eagles say, we're selling the design, so it can't cost anything, like how many grams or anything. But it should be for fundraising. Yeah, so.
Yeah, I just needed someone to like draw out the actual like board outline.
Yeah.
The cut line for
Can you
it.
import a picture?
I don't know, Jeremy, have you done a lot of custom like line work in this?
Yeah, how,
Because
like,
you-
we
very
want to make
basic.
a.
Custom line work for,
Like a board cut. Like a very customized board cut, not just a very simplistic one.
So
that
like
you can
the
use.
hearts, we're gonna make Eagles.
what's the question?
So he wants to make our Eastern logo, but make it light up like the heart and alternator. Problem with that is, trying to draw that kind of shape in these programs is really hard.
You can import it.
You can import, but what can you import from? That's what I'm wondering.
SVG for sure.
Okay. So
Actually, here, that'll be interesting for everyone to see. I'll go and do that because I'm going to add the Eagles logo to this, but I'll show you. You could probably
well, you
do it
can
as a
add
board
it as
edge.
like silk screen. I'm just gonna as an edge.
Yeah, it's the same thing.
Yeah. I figured there was a way. I just didn't know how you would do it.
Mhm. So you probably have to convert it to an SVG, and then there are limits to the size of the features they can cut out,
Yeah,
but it
yeah.
will probably be
When I was
fine.
thinking, I could even make like a
Like kind of like
toned
this,
down
right? But instead of this, it's
the eagle shape.
Eagle, kind of. Eagle is gonna be hard.
What was it? We can dumb down the actual edge cut design and then just have like a silk screen more refined design on it. It's not gonna be too hard.
Find this chair's fancier anymore.
Yeah, but it's at just the right height so you're gonna hit the desk. See?
Howdy, David. This is more low key. This is just for something for everybody to work on. So you're working on your different project.
This is more low key. There's like 80 components and 100 wires.
But I already gave it to everybody, and it will guide you visually through routing it out. You have to start somewhere. My first board had like 80 components on it. So I think this is pretty reasonable.
This is how much? How much?
Oh, I didn't even count. I can go get a count real quick.
Yeah, how can you count components?
Probably on the schematics gonna be the easiest place. Let's see, hide YouTube, put is Control A.
Can
Is
the
it gonna
people
give me
on
an
YouTube
out?
hear me?
What?
Ones like
Can the
that.
people on YouTube hear me?
Yes, the people on YouTube can hear you, all 0 of them.
Well, live, so it's saved, so.
Yeah.
People who are not here live, but
Uh,
watch it in the future.
And again, it's like, there's not really, I don't have anything much to lecture on other than individual things as they come up.
Yeah.
So it's not, if somebody missed this, like, and didn't watch the YouTube all the way through, that would be kind of what I expect. 'Cause it's more the, oh, here's the setup, now let's work on this.
10 more years, you get like a million things.
So let's see, where is actually a good way to count components? I've done it, it's just been a minute since I did it.
Control Shift C. That word count.
Probably not. I'm just gonna Google it, get a good answer.
Yeah.
What's VBAT attached to?
What is what?
VBAT?
I don't have anything connected to VBAT right now. I have that for an external power input, like from a battery or like a barrel jack. I will probably add that to the ops board. If you guys want to add something to your board, you can. So actually, here I'll explain what's going on here at the power supply up top. So you see we have VUSB and VBAT. Well, VUSB comes from the USB. So when you plug it into your computer, it'll power it. But we don't just want, or I didn't just want it to have to be plugged into USB in order to be powered. So I want it to be possible for you to plug it into a battery or anything else into this voltage regulator. So what the diodes do is they,
They'll,
simplistically describing it, they only allow current to flow in one direction. That's the way the arrow's pointing, right? So we're saying VUSB can push current in this direction, VBAT can push current into this direction. And this is so that VBAT would not backfeed into VUSB
yeah.
or vice versa. So these two won't fight. And then whichever one's the higher voltage is the one that's ultimately going to be VBus.
Oh,
This particular voltage regulator can handle up to 15 volts. So you can plug this into a 12 volt battery and everything will be hunky-dory. So, so that's what that is. I don't have anything hooked up to VBAT, but that's just the capabilities there. If you don't want to have that on your board and you just want to always power it through USB, you can get rid of that. I would not recommend removing the USB power because it's going to be really handy for programming it, so it's powered from it. You're going to put a pin to it? Perfect. I recommend putting 2 pins to it so you have a ground and a connection to it. Or you have a ground in the connection, so. How do I get a component count? Because I swear I've done this before. I guess I can do a bomb. I mean, I can always do it this way to answer the question. Okay. And it went and saved it. Opsboard.xml. Okay. I am pretty deep down the hierarchy there to where that is. That's what I get for trying to use Chrome.
Square typically negative.
What was that?
Square port typically negative.
Here, a second, because this just popped up. The what? Technically negative?
So when you have a solder pad that's circle or square,
There is not good consistency on that. In KiCad, most all of those are set up so pad 1 is square when you're looking at that. Yeah. For anybody else who didn't catch what that question was, when you go and look at the pin headers in KiCad, the footprints for them, they look like this.
yeah.
And they have like the first pin is marked out by this angle not being inside of here and then also saying, or also being square. I think they went a little bit overboard on it. But that's what that means is It's pin 1. It doesn't mean anything else. And you can change this like in your schematic also. Like if you didn't want that, you can go double click on it and change it back to circular right there in the editor. So you don't have to worry about it. Why does it want to open it with LibreOffice Writer but not Sheets? Yeah, it's not that many components. I'm sure there's a better way to get the count, I just don't know it. One thing,
What's the count?
oh, I didn't get the count. I'm not going to go through the trouble of opening up the XML file, but it's like, I want to say 30-ish components in total, maybe 40, vaguely.
You know why there's a big pink square around it now? These only showed up after I updated KiCad.
Yeah. I recreated it from the schematic they had.
So if you
It's on a weird layer or something.
go, yeah, so this is the mask, front mask, so you can actually just click the little eyeball right there, and it should hide it. Maybe it's back mask? Oh, also adhesive.
That's what these are. Actually, writing on the agencies.
Yeah, I don't know why it's got that on there. Go to objects here.
Oh, locked item shadow. That's it.
Ah, okay.
They're locked. It's kind of annoying to see. I can see why they have it, but
It's KiCad when you like reopen a file, the appearance tab isn't saved, and it just like resets to show everything.
might have been because I updated.
Yeah. Okay, so I have all my components placed. I know not everybody's caught up with it, but I'm going to start routing this out. And I mean, we only have 20 minutes left. I'm not going to go over because I don't have a bunch of material to get through to try and tell everybody about today. So I'm just going to start routing, and then everybody think about what you want to make and work on making it, and then ask questions like through Discord and stuff asynchronously. I guess that's all I really have to say more about it other than that, to answer questions as we go. And I'll still talk about stuff as I go through this though. The first thing I'm going to do before I start routing this for a larger design like this, I'm going to add a ground plane to the backside. And that is done with the add filled zones, which is this button right here, so everybody can actually see my cursor today. And you just like draw a polygon around where it is. You pick what net you want it to be. I want it to be the ground net. I want it to be on the back side, but not the front. And let's see, going to do thermal relief pad connections. This is so that if you have a pad, it won't just connect to it solid everywhere, because it makes it really hard to solder it, because it'll like pull the heat away really fast. You'll see what they look like when they show up on there. I'm going to hit OK, and then it's going to have me draw the polygon for where it actually goes. And I'm just going to draw a square around it that makes a zone. I'm going to click this to get out of the mode. B calculates the fill. It was B on my keyboard. Now you can see it filled it all in. These are the thermal relief connections that it makes to these. I'm going to go view, flipboard view to look at the back side, and then I'm going to hide the front side footprint so I can just look at the back side for the moment. I'm also going to hide the rat's nest. So you can see these are all ground, but instead of making a solid connection to them, it does these thermal relief connections, which is so that they're reasonably solderable. Because if it's solid, it'll just suck the heat away, and it'll be really difficult to do. Turn that back on. View. Board view.
This will be after you place everything, or does it auto move when you move things around?
So you have to press B manually to update the filled zones.
Okay, so you can just kind of move things around and update.
Yeah, and then I'm actually going to go and turn it off because it's really annoying to see while you're working.
Yeah.
But the advantage of this is like, okay, so this up here has a ground, and I need to route that somewhere. I'm just going to go, here, I've changed my net list. I'm going to do a larger size because this is a power connection. And I'm just going to go V for via, and it goes down to the ground plane. This, same thing, via down to the ground plane. And these are related. I'm going to connect them up here too. But that's a pretty common way of handling things. So I'm just putting these all down to ground now.
Should I do that too?
Yeah, you should probably do that too. So the other advantage to the ground plane is like, as you're trying to have good signal integrity, it's really important to have a low impedance ground connected to everything and make sure that everything's at the same voltage level. There's this phenomenon that's called ground bounce, because you can, when you actually make your ground, I'm just going to draw the board, like, when you actually make your ground, like you can have a component over here that has two pads, and you can go and run a trace all the way over here to another one that has ground. But if you're just running a trace, that trace has a certain amount of inductance and resistance to it. And if this right here, say, draws, let's for the sake of argument, say this is 0.01 ohms, but then you draw an amp over here of current, right? You draw an amp of current over here for whatever you're doing through that component. Here, actually, so you put in, so this is ground, right? If you have an amp that you're feeding into this component here, then you may find that there's actually a 0.01, in this case would be a 0.01 volt difference at higher frequencies, and you go and find out that this has an impedance at frequency of a few ohms.
Yeah.
This can actually get very significant. So you can look up calculators to tell you how much impedance there is in a given trace with a particular size, and it gets significant pretty fast when you get up into the megahertz region. So one way to, so what do parallel inductors do? So if I have this and it was an inductor and I have this in here, another trace, right? So now my inductance is half because that's parallel. Well, now what if I just go and fill the whole damn thing with copper? Way less inductance to worry about at those higher frequencies, way less resistance. Now when I say this is 0 volts, it's going to be 0 volts instead of this one turns out to be at 0.1. This one's at 0.1 volts, and this one's at 0 volts, So that's one good reason to have your ground planes. For the same reason, we're doing 2-layer PCBs for our designs, unless you really need a 4-layer. If you want to get into something special, you want to use VGA chip. You look at professional designs like a computer motherboard, and they need to really carefully control the impedance of things, and they have a million traces. They will have one layer that is power, they'll have a layer of signals, they'll have a ground layer, a layer of signals, a layer of power, as you go through the board so that those layers aren't broken up. Because if you have to say run a trace right here, you have a via that's going through, well, your effective use of this plane right here is much less if you go pop a trace in between it and just break it up. So they just want dedicated planes for those higher performance systems. So we only have one layer to kind of make a ground layer, and we have to break it up because it's a 2-layer PCB. But just keep that. The level that we're doing it with the RP2040, everything will probably just work if you did everything like wrong. So you don't have to worry about it too much. I just want to sort of talk about what I've learned a bit about doing it right. Does that make sense?
Okay, also act as shielding.
Yeah, so it's also, that's actually a very good question. So when you have what I was describing, like in a motherboard, you have a power layer, and you have a ground layer, and then you have your layer that has all your traces, right? All of these, one, it controls the impedance and the coupling to these layers, a certain amount of capacitance in between those. That is controlled for, and you can actually do calculations in KiCad with it if you put in all the parameters. You do a differential pair. You can tell what impedance you need. So for example, DDR3 RAM, I know needs a characteristic impedance of 150 ohms. So they go and say, this dielectric has to have this exact, the dielectric in between, like the fiberglass has to have this particular constant. This copper needs to be exactly this size. This layer needs to be exactly this thickness. And then we need a ground plane here and a power plane here that are our signal levels for those in order to get that down to where, you know, that if you're talking about DDR5 RAM, we're running signals that are like 2.5 gigahertz over several inches. And, you know, talk about that's like Wi-Fi frequencies running in your computer inside of these, and they need to have that travel over several inches, which is larger than any antenna you have in your device. How do you keep that from interfering with everything? This also creates a Faraday cage around your device. So you're not going and leaking this, you know, if you just go and put traces and run them at those high frequencies out there in the open, their antennas very easily, they'll radiate to everything. But when you go and put it in between layers here, you go and I've seen like, I've actually read application notes on DDR specifically and how to route it. So when that's a reason you do this, and they like had simulations to show like, hey, this couples to this like this for each individual trace, and there's this level of crosstalk between those. You know, there's a pretty big rabbit hole to get down when you get into high frequency design. And you know, so this is cool. You have to play with some of the low frequency stuff to understand what's starting concept first. That's what we're trying to do here. I enjoy this type of thing. I would actually love to sit down and write software that calculates this type of thing for PCBs. It's on my to-do list. So, does that sort of answer your question on that you had?
I enjoyed it.
I think for EE, I think we're gonna learn this in electromagnetism.
Yeah, an EMAG.
401. Dr. Rogers didn't talk more about that.
I don't know how much he gets into the practical side of design and stuff.
He doesn't have time to get to that, but like he touched on that. Just go mostly on the EM theory.
Mm-hmm.
But if you're interested, ask Dr. Rogers more on that too.
Okay. I feel like Dr. Rogers, like he's rather intimidating, but if you go and ask him about something you genuinely want to know, I feel like he's happy to share with people. So
it's less intense in office hours.
He's in office hours.
Huh?
Does he have office hours?
Yes. In the morning, usually at 10. In here though.
And Dr. Rogers has actually lived this stuff too. Like he did actual, he ran teams that did actual design for that type of stuff.
He worked for HP for a while, and he was doing those industry stuff.
I think he's one of the few professors here that does have that type of experience. So. What was that?
I had the pleasure of talking to him once.
Yeah. So remind me, where are you at in your education? Here or?
What year are you?
6 years of college, and this is the first university.
Okay. So are you doing E?
Yeah, electrical computing.
Okay. So you're going to get into all this in the coming couple of years then. we unfortunately, the EE classes talk about the analysis, but we don't really talk about the practical stuff. The reason I know these things is because I've gone and researched it on my own. And then more and more as I get into my education, like I haven't taken EMAG yet, but I know enough base to understand the research paper, not research paper, but like the specification put out for DDR. They go and try to explain these things, and they don't try to explain it, they don't try to get into the weeds, they try to explain it at a high level, and then you have to have the basic knowledge to understand what you're looking at.
I've noticed a lot of the education is a white canvas.
Yeah.
And
It's a lot of
you go outside and you're like, oh, that's where all the paint is.
Yep, exactly. We're like, in microelectronics right now, our final project is design a rectifier and an amplifier, and we're gonna feed it with a signal generator. And I did like hobby electronics stuff before, and that was breakfast because it's such like a basic thing like to do if you're actually making a circuit. It's like, I have an AC, I have power at the wall, how do I get that to my device? You have to go and build a rectifier. There are different ways to do it. You have to build a rectifier to get there, so you just end up doing it. And you don't even, you're not thinking about, I had to spend a week on this in microelectronics. You're thinking, how the heck does this work? And you figure it out. So, like my project, so I took Circuits 2 over at North Idaho College, and we went way overboard for the final project. We got a transformer, and we built a rectifier, and then we built an arbitrary signal generator out of op amps to go on it. But it's like we already did
You did like 3 finals in the wind final.
Yes, the extra credit from that project was the only reason one person didn't fail. It was the only reason one person got a B instead of a C. And it was the only reason that one person got an A. There were 3 people in the class. So he gave us enough extra credit on that project to bump everybody's grades by 1 level, so we went overboard.
Nice. Yeah. And Circuits 1, just a new Python one.
New Python.
163?
Yeah. Where the final is like, use a microcontroller to turn on an LED. And it's like,
Is this Reisberg? Okay.
Yeah,
Here
I
don't know.
my infrared mode out and my motors and.
I posted the video of my final project for that class Discord. Did you see it?
Oh man, I need to. I want to squash
Dr. Rogers has been.
It's not like a presentation video. It's like me hurrying recording it in case it catches on fire, because it did that once before. But that's another circuit board design that I did. Okay.
And Dr. Rogers haven't paid you yet, right?
No, he hasn't. It's out of his hands now, though. Jane had me fill out a tax form for the reimbursement.
Oh, nice.
So it's in the works. Well, that's why like 4 or 5 times I was like, I'll just give it to you. I'll just give it to you. And he like insists that I get reimbursed for the parts. So, let's see. I posted it not too long ago in here, I think.
It's the,
Yeah, here. This was my final project for 163. I can't stand to listen to myself talk, so I'm going to mute it. But so I have potentiometers on there to control the like oscilloscope, and the Pi boards that you use in 163. That's one of them stuck on there.
I like how you just modularized it and just stuck it on.
Yeah. Well, we had to use the Pi board. If we didn't have to use the Pi board, I would have done this and used the RP2040 to do this design. Actually, the Pi board's has better ADC than the RP2040.
That's crazy. So, did you go through this with Roger?
Not really. I just kind of did this myself.
Okay.
He was like, I can't believe you put this much work into it. I'm like, what do you mean? This took 6 hours.
Did you base on
Go on to
any,
the thing
like,
where,
No.
I mean, did you base on any like online designs or like?
No, so I've already built like an arbitrary signal generator out of op amps. That is
Gotcha.
way more intense than reading in something from an ADC.
Okay.
So reading in something from an ADC and then programming it to display on the LCD wasn't that difficult from there. So it's like, this is like, yeah, this is PCB project number like 50 for me at this point. So I'm like 6 hours is about all I spent on it, like from start to finish.
Why didn't you take off the screen protector?
Because the screen protector's on the thing and it's not my LCD.
Oh,
It belongs to the class.
I didn't know that.
paid for it, but yes.
That's nice.
So yeah, I left the screen protector on it, and yeah,
Do you still have the code for that?
I do still have the code for that.
That's really cool.
So, but yeah, the video's on Discord, and actually, I don't remember whether I posted the the source for it, but I have the source for it. Let's see. I'm logged in remotely to my desktop at home. It's probably in my workspace here. Here it is, Pieboard oscilloscope. Oh, well, that's not everything I need.
It's just the invoice.
It's just the invoice that I sent. It's on my, it's on my Git, now I remember, it's on my GitHub, but it's in my repository that has all my homework in it. So that's why I didn't post it. So this is like all my homework from that class.
I'm interested in seeing your, just like glance.
My Python code?
Yeah.
Sure. Do you want to see the code for the Pieboard oscilloscope? There, firmware.
Do you also write that in Python?
It's all Python because the class is in Python.
Oh, okay. I missed that part.
Yeah, so the class is all in Python. This is, let's see. Because he requires the documentation. I'm going to download this because the viewer here sucks. I guess it actually is. So he requires documentation as part of your grade, and he dinged me a couple times for not having enough documentation, so I just went overboard. So class oscilloscope, documentation. He says no more than 80 characters in a line, so that's why it looks ugly, because I have more than 80 characters in pretty much every line. So like, at a glance on this, I just like made a class that's oscilloscopes. I did it object oriented. I have a few like methods with the class to read the states of the ADCs and to take the input from the LCD and so on. When I get down to the bottom here, I just have a while loop. So I take the input, read in the values from all the channels, and then draw the screen. And he said in his requirements you have to use a function, and after me he said main is not a function anymore for purposes of this assignment because I didn't write an actual function. I'm like, I've written a lot of functions for you in this class.
Unfortunately, that's methods.
So I used methods here. Main is technically a function, and main is not special in Python. But I'm like, let's see. Which homework was this? Which homework has the 20 kilobyte Python file? No, not this one. I think it's homework 5? Homework 6, maybe? I'm like, this homework assignment is 3 files, and this one file is 850 lines.
Facebook's been nice to us. We haven't required any of this craziness.
Yeah,
I
so
would want this, but
you what?
I would enjoy having Yuri. It requires a lot more.
He does. He really. I had a hard time getting an A in 163. That's why it's like, okay, I didn't get 100% on this assignment. Turn the dial up again, turn it up again, turn it up again. By the time it's done, I'm like, okay, here's 3,000 lines of code, and I did literally everything. And then he gave me a 98 on this one, minus 2 points, too complex. So maybe I'll pull out the Pieboard oscilloscope and put that up on GitHub without the rest of my 163 code, because I would get in trouble if somebody got the same assignment and then copied my 3,000 lines of code. So that's why usually it's a private repository in here. But yeah, I had a lot of fun in that class, but I put more work into that class than I did in any of the other classes I took the same quarter. And it was a 100 level class, so I think the only assignment in that class I got 100% on was the final project, because I think building an oscilloscope in a 100 level class, he was like, okay, fine, here's 100.
Alright. I think we're at 4 p.m. right?
Yeah, we're at 4. I mean, nobody had to be here anyway, but anybody can go.
Yeah.
Does anybody have like a project idea they want to do or want to talk about? Like, Okay, sure, David.
I had a question.
Do you want to share your project with the class?
Yeah, sure.
No, how did you do the fill?
How did I do the fill? Okay.
Yeah, so I clicked the
I'm gonna
fill
answer this
thing and then
question
it
first.
just didn't like fill it.
So, press B. Did you pick a net? Where's your lines that you drew for it?
I don't have it now. There isn't a net or whatever. I got rid of the thing that I drew because it didn't seem like it worked. So this is starting from scratch.
Oh, did you do a schematic with it? Or, oh, so start your fill.
Yeah, I
click.
have
Okay. So now, oh, you don't want mask for sure.
not mask,
You want front copper. So just expand that out.
but I like it this way. Front copper or back copper? Which one is it?
I use back copper for ground, but it doesn't matter.
Where's back copper? Jeremy,
What was that?
where's back copper?
It should be in there. Scroll up.
That's it. Did I get rid of my copper?
I think you deleted your copper layer.
How would I have done that? All I did was update the damn program. Oh, I knew updating to KiCad.
Scroll up. Let's see. No, you have copper. It's got to be in there. Oh, is this graphical fill? Did you do?
Oh,
there it
okay.
is. You were on graphical fill. That's why.
Okay, thank you.
Did you solve that same issue?
What was that?
Did you solve that same issue? Yeah, over 60.
Yeah, it's non-power.
It's like there's still.
So they could have that. Oh, so you have a non-popular select, that's what it was. Now when
Or
we're
say
doing
he's only got about half the current ones total. So like, he's messing with the rest of the class.
If anyone wants an idea for a project, like a good, like LED controls, like to light up and have like Eagles logo on it, would be a good for our club to do like a fundraise and then you can put in your like portfolio too, your resume. Put it in, that'd be a good.
So actually just like more general, like something you
Yeah.
can do that would be really cool with this is make something like holiday themed.
Yeah.
For any holiday you want, just have lights. You have like 25 pens to work with for lights that can light up. So you could have a bunch of different LEDs on a Christmas tree. You could have, whatever you're into.
Like this.
You can make something with it that lights up and just, you can program it and have the lights do a pattern or whatever you want. It's just something like that simple. It's not a bad way to get started.
A good kind of like starter. And then just make it like Eagles theme. So like it's good to showcase or holiday.
You can also import images to KiCad and use them for layers. So you can import an image and use it for your edge cuts layer. So you like find a picture of a tree, import it on the edge cuts layer, and then have them make you the board in the shape of the tree. So you can do that in the slip screen. Like I'm gonna go do that to add the IEEE logo to the boards that I make. You had to turn to look on your face for a minute, Sarah.
Oh,
How are things doing?
good.
You good? Okay.
It's a pretty cool three-color stuff we're gonna do, or four-color, where you do the exposure hats and the star hats. That's so
See you in 2 weeks.
Oh, I was gonna show really quickly, since everybody's still here, and I forgot to show before the time's up, how to do the fabrication outputs. So if you order a board and it's not with us in a group, you know how to make your fab outputs. I don't know why this screen turned off at 4, like it does every time.
4 o'clock.
Why is 4 o'clock special?
They don't expect any classes after 4 o'clock.
So just automatically turn it off to save power. That's probably it.
Probably. It's a smart building.
It's
Smarter than
It's
us.
supposed to be a smart building. It doesn't seem like it.
Yeah.
Okay.
I got
so-
a stupid question. Does KiCad have mouse support?
Mouse support?
I'm using a trackpad.
Yeah, that's painful. There's a mouse right
You're
there.
telling me.
Yeah.
You can plug a mouse in. Okay, so for fabrication outputs, just
My
really
USB
quickly,
somewhere.
after you have your board done, when you go to do your fabrication outputs, I highly recommend doing inspect design rules checker and then run this. Don't run it right now because it's going to throw errors all over your board, but I'll just show you. So it has 91 errors and it's going to tell me, hey, this board right here, or this right here is in a place that it's not going to come out well. And I'm going to pull this back up. There's a violation of hole clearance here. You can ignore courtyards overlap. Usually, you can actually go and say exclude this, change severity, etc. Board has malformed outline, no edges on edge cuts layer. Because I didn't draw the edge cuts layer yet.
Your silk is over the cut.
Yeah, so there's no edge cuts layer, so it's giving a bunch of things to complain about it. Hey, this is overlapping silk screen for another thing.
And
It will.
that's generic.
So this is like all the things that they could think of that are errors. So it will tell you, hey, this isn't connected. So like there's all these unconnected items. And there's all these violations. So this is part of the reason we set up ahead of time all of our design rules in the board. So it's able to warn us before because if you can generate your fabrication outputs and send them over to the manufacturer, and then they're going to send them right back and say, we can't make this. Or in the case of JLC PCB, they'll say, we'll try, but it'll be twice as much. They actually do.
Screens on someone else's board.
But yeah, and JLC PCB actually like makes subtle changes to your boards if they don't fully comply with their specifications. You don't want that to happen, you just want it to comply. So anyways, after you've run the design rules checker, just housekeeping ahead of time, make sure you didn't forget to connect anything that's in here. So basically that means that your schematic and your board layout match. And then you're going to go over here to fabrication and outputs. And it used to be plot here, but I think they have this. So this actually just changed. They have this fabrications output thing to get there. It's the same thing as the old plot menu. This is correct already in here. You want the edge, you want all these layers that are currently selected. So your copper, paste, silk screen, mask, and edge cuts. If you are not planning to get a stencil, you can turn paste off. So the paste layer, as I mentioned last workshop, is where solder paste needs to be. And if you're planning to get a stencil made for your board to place solder paste on it, then you need the solder paste layer. If not, you can leave that one out. I'm going to leave it on. For the manufacturer we use specifically, JLC PCB, we want to turn on use Protel file name extensions. And then, let's see, other than that, I think that's all we need to do in here. You used to have it change like everything, but KiCad updated so that they pretty much match what the manufacturers want usually. So you're going to go do plot, and then it goes and creates all these Gerbers in here. So it made all those files, they're called Gerbers, but you also need to generate the drill file. So down at the bottom here, there's generate drill files. And you can pretty much just use the default settings in here. You want to make sure that you put plated through holes and non-plated through holes in a single file, because they only accept one drill file at the manufacturer we use. It's like an automated system. So then generate drill file. And then we go to where our project is at, which I literally I'm logged in on my computer. I mounted remotely my computer at home. So this is why this is like so deep in here. And then, let's see. Usually I'm going to back up and go back to KiCad and say, put something in for output directory here so it doesn't put them in with everything else. So Same thing. Single file, generate drill file. And then I go over to this, and now there's this typoed fab folder that has everything in it. So these are your Gerbers and the drill files. You have to put these in a zip file. I'm on Linux, so this is going to look a little different than what you would do on Windows, but basically you just make a zip file and put them in there whichever way you do it. Let's see. One of those ought to work. There we go. It's zipping and it's done. So this zip file is what you actually upload to the manufacturer. So I'm going to go to jlcpcb.com. I'm going to log in real quick. Otherwise it's going to prompt me to. And then on their website there's this add Gerber file button. You go to that and, oh, I'm going to have to dig apparently. Workspace, remote, alpha, home, J.K. Munson. Workspace, ops board. Okay, finally. You upload a single zip file, that's the only way they let you upload it. And it's actually pretty similar across all the PCB manufacturers. And then it will show your board the way they interpreted it on the PIT web page here, and then it will automatically fill out as much stuff as can. I don't have an edge cuts layer, so it literally doesn't know what size to make the board. That's why this isn't filled out. Okay, fine, 200. There we go. This would be $69 at that size. It's a much larger size what I entered in. You can see there's a bunch of different, these are actually new. I don't know what these are just yet, but there are different options for a board. We just use the regular FR4 for what we're doing. Aluminum and copper core are for like lighting applications, like high power LEDs. Instead of fiberglass, they actually have aluminum like core in them and then a thin layer of fiberglass. So it transfers heat away a lot better. For example, there's actually a lot out there in terms of different choices for substrates, but almost everything's fiberglass, and then these are kind of special. And then you can set all the settings. Particularly, I want to show everyone that you can pick colors in here. So if you want your circuit board to be white, you can make it white. If you want it to be blue, you can have them make it blue. This is relevant if you're going to do something like a Christmas tree. You'll probably actually just want to stay with green. But if you're trying to make the EWU logo, maybe you want to go with red. Pretty much everything in here you can leave default. I usually pay the little extra charge for lead-free because if I'm handing my circuit boards to people, I don't want them getting lead on their hands, and I'm responsible for that. So I usually choose lead-free in there, and if you don't pay the little extra, remove the order number, then they put a little number on your board somewhere, and sometimes they put it in really obnoxious locations. Like right in the middle of your description of your project, they'll just go and slap it in the middle there. They can't read English, so it's a Chinese fab. They don't know what they're doing. They just go and they're like, here's enough space to put the order number, and they put it on your board in the silkscreen. So I usually pay to remove that. Oh, they charge extra for lead-free and red now, apparently. That's annoying. But not for purple. It'll tell you what the cost is. So you see for this board right now, if it was 100 by 100 millimeters, I could get 5 of them for under $5.
Ships in 2 to 3 days, or?
Yeah.
2 to 4.
Yeah, it's pretty fast. Like I've ordered and had my boards in hand in a week. So it's variable. I've also ordered and had my boards in hand in 3 weeks. So it depends on how backed up they are. That was during COVID, so.
Everyone's bored.
Well, that and also they shut down for a while, so. There's also, I'm not going to get to in this workshop, but you can make all the outputs from KiCad to do PCB assembly, and then you can specify to have them put all the components on the board for you. So this would be more akin to a professional product. I need 5,000 of these, and you go and pay them to put them on, and they're actually pretty cheap.
127 bucks cheap.
What?
127 bucks cheap.
I don't know why it's, let's see. I don't know why it says 127. Oh, that's because it went and selected the 6-layer. 2-layer PCB.
Oh, 6 though.
There we go. With assembly, their starting price for it. Okay.
So a lot of it.
So they charge $25 plus they charge you for a stencil, and then they're going to charge you a certain amount per component and a certain amount per joint. So the per component cost, if it's in their standard basic parts library, they don't charge it, but if it's a part that they don't have like already loaded in their machines, they charge you $3 each. So you can get there. Yeah. The one time I did it, I ended up paying $45 for 20 boards in total, manufactured and assembled with all the parts. It wasn't bad.
Yeah, that's pretty
Ship
good.
to,
It's like
or
500
is that
bucks.
included?
And that was the motor controller board I showed everybody at the one workshop. I had them place everything on there except the through-hole components, which they wouldn't do at the time. All right, I'll stop talking so people don't feel like they have to stay.
I'm enjoying it.
It's good stuff.
Come hang out with us and design stuff.